She stands in New York Harbor. Green oxide coating on copper skin. Torch raised, tablet gripped, crown spiked. Everyone knows her outline postcards, movies, license plates, immigration stories, patriotic montages. The Statue of Liberty exists as shorthand for arrival, freedom, American identity itself. She has been photographed millions of times. Her symbolic weight is enormous, often hiding the physical structure underneath. But this is not a story of symbolism. It's the story of 31 tons of hammered copper, 125 tons of steel framework, and 27,000 tons of concrete and granite, assembled across an ocean through diplomacy, engineering, improvisation, and financial desperation. It begins not with ideals, but with practical problems that nearly killed the project before a single rivet was set. The statue that would become an icon almost never happened, not because of politics or war, but because no one could figure out how to pay for it, ship it, or keep it standing once assembled. The idea emerged in France during the 1860s. Édouard René Laboulaye, a legal scholar and political thinker, discussed the notion of a monumental gift from France to the United States. This was during the American Civil War and the French Second Empire under Napoleon III. Laboulaye admired the American Republic. The gift would celebrate the centennial of American independence in 1876 and affirm Republican values while France was politically unstable. The concept remained conversational until sculptor Frederick August Bartholdi became involved around 1870. Bartholdi had experimented with colossal statues. He traveled to Egypt in 1855, sketching monumental figures. Scale appealed to him not just artistic expression, but an engineering challenge. When Laboulaye's idea gained traction, Bartholdi saw an opportunity. He visited the United States in 1871, scouting locations. He identified Bedloe's Island in New York Harbor, small, visible from multiple angles, federal property, perfect for greeting ships. But arriving and building there were separated by an abyss of technical unknowns. No statue of this scale had ever been attempted in modern materials. The tallest structures of the era were masonry, cathedrals, and stone monuments. Metal statues existed, but nothing of Bartholdi's envisioned scale. He sketched a robed female figure, arm raised, holding a torch titled "Liberty Enlightening the World." The preliminary design made the figure roughly 151 feet from base to torch. That height required rethinking every assumption about sculpture. Bronze casting was impossible. Solid bronze would weigh thousands of tons. Stone carving would take decades and be fragile. Bartholdi needed a lightweight, weather-resistant, workable material. he settled on copper, hammered into sheets using repoussé over wooden forms attached to an internal framework. Copper would be only 2 4mm thick, less than 2 pennies stacked. Thin copper couldn't support its own weight. It would buckle under wind and temperature changes. The statue needed an internal skeleton strong enough to hold copper, yet flexible for expansion and contraction. Bartholdi's artistic vision collided with 19th century engineering limits. He approached architect Viollet Le Duc, who proposed sand-filled masonry to support the copper. Bartholdi accepted initially, but Viollet Le Duc died in 1879, and the plan was abandoned. Bartholdi then sought someone experienced in metal structures. Enter Gustave Eiffel, already known for metal bridges and railway structures. Eiffel saw that this was not a sculpture problem, it was a structural engineering problem disguised as art. He designed a central iron pylon with secondary armatures supporting the copper skin, flexible enough to expand and contract. The sliding joint system allowed the copper to move independently of the iron. This principle was revolutionary and later used in skyscraper curtain walls. Eiffel calculated wind loads, weight distribution, and stress points. The completed statue would weigh around 225 tons, manageable if the pedestal was strong enough. The French would build the statue. Americans would build the pedestal. Fundraising began in France in 1875 through lotteries, donations, and municipal campaigns, raising about 400,000 francs, enough to begin construction but not complete it. Bartholdi set up a Paris workshop. Copper sheets were hammered by hand over full-scale wooden molds. The statue would be built in sections: head, arms, torso, robe folds, then assembled. Miscalculations of even a few centimeters could ruin compatibility during final assembly. The head and torch arm were completed first and displayed to generate publicity and funds. The torch arm was exhibited at the 1876 Centennial Exposition in Philadelphia. Visitors could climb inside, but the rest of the statue was still under construction. In New York, the pedestal planning barely started. Richard Morris Hunt, a prominent American architect, was commissioned to design it, a massive granite and concrete structure rising 89 feet above Fort Wood, requiring 27,000 tons of material. Costs were high, fundraising was slow. By 1884, only $182,000 had been raised. Construction started and stopped repeatedly. Meanwhile, in Paris, Bartholdi's workshop operated at full capacity. Craftsmen built full-scale plaster models, wooden molds, and hand-hammered copper sheets from Norwegian copper. Each copper plate required hundreds of hammer strikes. Iron straps connected the copper to Eiffel's framework via sliding joints, allowing thermal expansion. The central pylon was 96 feet tall, with secondary iron bars extending to extremities. The right arm holding the torch was an engineering challenge. Eiffel reinforced the pylon and shoulder bracing. Copper pieces were numbered and assembled in Paris to ensure proper fit in New York. By 1884, the statue stood complete in Paris. Photographs captured the fresh, reddish-brown copper, soon to develop green patina. The structural system worked perfectly. No buckling or failure occurred. In New York, the pedestal remained unfinished, granite stacked about 15 feet above Fort Wood. Then halted due to lack of funds. Joseph Pulitzer launched a fundraising campaign through the world, printing donor names to shame elites and encourage small contributions. Within 5 months, over 120,000 people donated about $102,000. Combined with earlier funds, the pedestal budget was secured. Hunt resumed construction in April 1885, pouring 52 feet of concrete into bedrock and stacking granite blocks with precision. The pedestal's walls were solid, no hollow spaces, designed with Aztec revival and neoclassical elements. Staircases inside allowed visitors to climb to the statue's base. The pedestal reached 89 feet in April 1886, with a square platform 65 feet on each side. Anchor bolts were set in the concrete for Eiffel's framework. Precise alignment was critical. Any misplacement would prevent assembly. The central pylon and secondary skeleton were lifted, aligned, and bolted to the pedestal. Copper sections were lifted from bottom to top, secured to the iron framework with sliding joints. Rivets connected the copper sections along seams. Interior scaffolding allowed crews to work in cramped spaces. Exterior scaffolding provided access from outside. The right arm and torch required chains and pulleys to hold sections while attaching them. Wind gusts slowed work. Summer heat caused metal expansion. Measurements varied between dawn and noon. By September, torso and head were complete. Crown spikes were attached individually. Face measured over 10 feet from chin to crown. Tablet in the left hand was secured last. 23 feet tall, 13 feet wide, with thicker copper to prevent warping. Robe folds were carefully positioned for aesthetics and rigidity, adding geometric strength like corrugated cardboard. By late October 1886, assembly was complete. Green patina began forming. Interior stairs provided access to crown, 154 steps from pedestal top. Dedication ceremony on the 28th of October, 1886, attended by President Grover Cleveland. Naval parade filled the harbor. Bartholdi unveiled the face from the crown. Crowd erupted with ship whistles and foghorns. Speeches faded into the noise. The structure stood after 15 years of struggle, engineering, innovation, and physical labor across 2 continents. Initially a symbol of Republican ideals and friendship, its position in the harbor transformed it into a marker of arrival for immigrants. Ellis Island opened in 1892. Millions passed the statue. Copper patina provided protection, though early observers feared corrosion. Eiffel's internal iron framework suffered from condensation and galvanic corrosion over decades. The torch was modified in 1916, adding glass and electric lighting, causing additional water infiltration. Throughout the 20th century, structural deterioration continued. By 1984, engineers replaced corroded iron with stainless steel, preserving Eiffel's sliding joints. The 1986 Centennial Restoration confirmed Bartholdi and Eiffel's ingenuity. 1880s. Materials withstood salt, air, wind, and temperature extremes. The thin copper skin, hammered by hand, remained intact. Structural principles stood the test of time. Today, 4 million visitors climb the interior stairs annually. The crown is accessible, the torch remains closed. Eiffel's framework functions as designed. Sliding joints allow independent copper movement. The statue remains both a structural marvel and cultural icon.
The completed Statue of Liberty stands tall in the harbor, torch raised, crown spiked, copper gleaming green in sunlight. Pedestal solid and proud, 31 tons of copper, iron framework, and 27,000 tons of granite and concrete, combined into a colossus that continues to inspire awe and symbolize freedom worldwide.